All right, so last time we learned about these things called conversion factors. Just as a reminder, conversion factor is a fraction that's equal to 1. So the quantity in the numerator and the quantity in the denominator are the same. They have different units though, and so that still allows us to have a fraction equal to 1. When we are working with conversion factors, the math that we're doing is multiplication and division. That's all we're doing. We're multiplying numbers across the top. Any numbers that are on the bottom of a conversion factor, we're going to divide. And so in terms of significant figures, remember, we round our answer to the least number of significant figures that was in the numbers we multiplied or divided by. Now, be careful. There are some exact numbers that we're going to deal with as well. And so primarily, a lot of times we're looking at the quantity that we start off with. That often determines how many sig figs in our answer, but not always the case. So again, this is a very, 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 very important skill, being able to convert to units, and especially converting with moles. All right, again, another review. When using dimensional analysis or unit analysis, the unit to be canceled. Now, this is, I don't know if this is an always. For now, in this class, will always go on the bottom, and then the unit that you're converting to goes on top. Just know there may be instances where the unit to be canceled is going to go on the top, but that's not going to be the case with all of these mole conversions. So cancel goes on the bottom, the unit you want goes on top. All right, let me walk you through a problem. This is going to be the longest type of problem you will do so far. And so anything that is less than this is shorter and hopefully easier for you. So I just want to show you all the possible conversion factors you could have in a calculation thus far in the class. So please go ahead and write this question down in your notes. Pause the video if you need to. It says, how many hydrogen atoms are in 25.0 grams of water? So we have a certain amount of this compound, a certain mass of this compound, and we want to determine how many of a particular type of atom, in this case hydrogen atoms, are in the compound. So pause the video, write the question. Okay. Always, like we did with the conversions involving eggs, start with the quantity given to you. And I'm going to want three things. I want the number, the units, and the formula of the substance throughout your work. So let's write that down. And if you can, start way over to the left. Sorry, I should have said this beforehand because this is going to be kind of a wide calculation. So we have grams of water. We're going to first convert that to moles. So let's draw a conversion factor. Very, very, very important. What is the relationship between the amount of a substance in grams and the amount of the substance in moles called? This is extremely important. Pause if you need to think about it. I'm going to say it one more time. What is the relationship between the amount of a substance in grams and the amount of that substance in moles called? This is something we learned just in this chapter. There's a name for it. Pause the video, see if you can remember what that is. This is known as molar mass. Again, look at the definition of molar mass. The mass in grams of how many moles of a substance? 1 mole. Okay, so that's what we're going to use here. So just like with our conversions with eggs, units first. Please, please, please do not just go and put in numbers. Units first. So we have grams of water. We need that to cancel. So where's grams of water going to go? That's going to go on the bottom. And what did I say we wanted to convert to first? Well, there's no way we're going to get to hydrogen atoms directly from grams of water. So we need to first find moles of water. So moles of water goes on top. One more time, how do we convert from grams of a substance to moles of that same substance? We use something called molar mass. We did this. We did these calculations. So first of all, how many moles in the definition of molar mass? 1 mole. So every time you use molar mass as a conversion factor, for moles, put a 1 next to it. 1 mole of water has what mass in grams? We've done this before. We've calculated molar mass. So that comes from the periodic table. So I'm going to round that to 3 sig figs. So molar mass of water, 18.0 grams per mole. So again, notice this, sometimes the grams will be on top and the moles on the bottom. Sometimes grams on the bottom, moles on top. That's still grams per mole. So let's cancel our units that need to cancel. And what do we have at this point? So at this point in the problem, I don't want a number. We're just looking at units. At this point in the problem, we have moles. And so we want to next convert from moles of water to molecules of water. So let's do that. And anytime you're converting between moles and particles, molecules, remember, are particles, make your conversion factor really wide. So where must mole go in our second conversion factor so that it cancels? That'll be on the bottom. And what did I say we were converting to? We're converting from moles of water to molecules of water. How do we convert from moles to molecules, or the other way around? What is the relationship between the amount of a substance in moles and the number of particles called? This is known as Avogadro's number. So again, in our conversion factor, in fact, let's say this. Every time you have mole, the unit mole in your conversion factor, it will always be 1 mole. Until next chapter. So for now, 1 mole. So 1 mole of water, or 1 mole of anything for that matter, is how many particles? Now again, let's back up a second. Why did I put molecules there? Well, water is a molecular compound. The particles of a molecular compound are called molecules. Now, if this were an ionic compound, the particles of an ionic compound are called formula units. So make sure you label that correctly. So 1 mole is Avogadro's number of particles. So at this point in the problem, we have molecules of water. We're almost there. We have 1 more conversion factor. So next conversion factor, we're going to convert from molecules of water to hydrogen atoms. So we need to cancel. We need to get rid of molecules of water. So that's going to go on the bottom. And then again, on the top, look at the question. How many hydrogen atoms? So up top, H atoms or atoms H, either way is fine. So for this conversion, we want to use a ratio. How many hydrogen atoms are there per every 1 molecule of water? So for this conversion factor, all we need is the chemical formula of the compound. So according to the formula for water, there are 2 hydrogen atoms for every 1 water molecule. Molecules of water cancels. What are we left with? We're left with hydrogen atoms. Is that what we were trying to find originally? Sure was. All right, go ahead and pause the video and do this calculation. Remember, for Avogadro's number, use your EE or EXP button. I'll walk you through in case you got the wrong answer. Pause now, please. And hopefully you got this value. So again, make sure to circle or box your answers to calculations so it's real easy for me to find your answer. So how I do it, I don't do 1 conversion factor at a time. I do all of the multiplication, then all the division. So walk through me if you will. 25.0 times 6.02 EE or EXP, whichever button you have, 23 times 2, so I just did everything across the top, divided by 18 equals, and you should get 1.67 times 10 to the 24th hydrogen atoms. All right, let's try another. In fact, I think I will let you do this one. I'll give you the opportunity to practice on your own. This is a lot shorter than the problem we did together. I'll walk you through it though to make sure that you set it up correctly. How many, what are we trying to find this time? So it's important we analyze the question, know what we're given, and know what we're trying to find. How many molecules of what substance? So in this case, it's carbon dioxide. That's again, CO2 is a chemical formula. How many molecules of carbon dioxide would you have if you had 2.50 moles of carbon dioxide? So we're going to convert from moles of CO2 to molecules. Question, can we convert directly from moles to molecules? The answer is yes. So this calculation will require one conversion factor. Think about what you will need to do that conversion. You have three choices that we've learned so far. Look at that problem at the top of the slide there. Molar mass, Avogadro's number, or chemical formula. We're going to use one of those three things as our conversion factor. Go ahead and pause the video and set it up, and then we'll compare. All right, here's the setup. We're starting with moles. We're going to molecules using Avogadro's number. And so your calculator, I think, says 1.505 times 10 to the 24th. We want 3 sig figs. Both of those numbers have 3 sig figs. Oh, something you might be thinking about. What about that 1 mole? Why not in the example that I did at the top, and why not in this example does the answer just have 1 sig fig? Well, that 1 mole, or in the last conversion factor on that first problem, the 1 molecule, that's an exact quantity. By definition, there are 6.02 times 10 to the 23rd molecules per every 1, exactly 1 mole. In fact, that 1 mole for the molar mass as well. Molar mass of water, 18.0 grams per 1 mole of water. So that 1 in moles is an exact number. It will never be used to determine the sig figs in your answer. So again, we're looking at sig figs in molar mass, sig figs in Avogadro's number, sig figs in the quantity given to us in the problem. All right, try this one out. How many grams this time of carbon dioxide, again, chemical formula CO2, would you have if you had 0.143 moles of carbon dioxide? Can you convert directly from moles to grams? The answer is yes. And so again, this calculation will require one conversion factor. Go ahead and pause the video and set it up. All right, so we're starting with moles. We're converting to grams. How do we convert from moles of a substance to grams of a substance? I want a name. That name is molar mass. And so we're going to use molar mass as a conversion factor. Again, please put your units in first and then the numbers. It's very easy to mix up where the numbers go if you put them in first. So 44.0 grams of carbon dioxide per 1 mole. We end up with 6.29 grams of carbon dioxide. Question, what is the relationship between 0.143 moles of carbon dioxide and 6.29 grams of carbon dioxide? They are exactly the same, just different units. That's all we're doing here, converting units. All right, try this one out. I may walk you through the next one just to make sure, but this one I think you can do on your own. How many molecules of ammonia, chemical formula for ammonia is NH3. Now I know what you might be thinking, wait, that sounds familiar. Ammonium, well ammonium is an ion, NH4+. Ammonia is a molecule or molecular compound. So be careful with ammonia, the compound, versus ammonium, the polyatomic ion. So how many molecules of ammonia would you have if you had 2.50 moles of ammonia? Pause the video, set it up. Go fast, please. And what did you get? That number looks familiar. Didn't we get that for an answer for one of our other calculations? I believe so. Why did that happen? Well, look at the quantity. 2.5 moles of one substance is the same as 2.5 moles of a different substance. Remember, Moles is the same quantity no matter what the substance is. Same quantity in terms of the number of particles. Maybe not the same mass, but the same number of particles. So 1 mole of anything is 6.02 times 10 to the 23rd particles. 2.50 moles of anything is 1.51 times 10 to the 24th particles. All right, let me walk you through number 4 again, just because I haven't walked you through a problem except for the first one. So how many molecules, that's what we're trying to find, of hydrazine would you have if you had 125 grams of hydrazine? All right, always start with the quantity given. Again, this is going to be a pretty long calculation, so start way over to the left. Number, units, and formula of the substance you're dealing with. All right, where are we going? Can we convert directly from grams to molecules? The answer is no. So what do grams and molecules have in common? Well, they have moles in common. So let's do this. Let's first take grams and convert that to moles, one conversion factor. And then we'll go moles to molecules, second conversion factor. So I'm gonna draw both conversion factors now, and then we'll set them up one at a time. All right, first one, we need to get rid of grams, so that goes on the bottom. We want to first convert to moles, so moles goes on top. Again, question, how do we convert from grams of a substance to moles of a substance? Give me a name. That name is molar mass. So again, molar mass, we have 1 mole. 1 mole of hydrazine has what mass in grams? Go ahead and pause the video and calculate that number, please. So at this point in the problem, we have moles of hydrazine. So let's continue from there. So where must moles of hydrazine go in our second conversion factor so that it cancels out? And what are we trying to find? The question asks for molecules, so that's going to go on top. How do we convert from moles of a substance to molecules or formula units or atoms if it is an element? Be careful about calculating atoms. It's different for atoms in an element versus atoms in a compound. So know the difference. So 1 mole is 6.02 times 10 to the 23rd. So we use Avogadro's number. Go ahead and pause the video and see what you get. Hopefully you got that answer. If not, let me know later and I'll help you out. All right, number 5, go ahead and give that a try on your own. How many atoms of oxygen would you have if you had 1.25 times 10 to the 25th CO2 molecules? So it doesn't say that in your notes, so make sure you add that. 1.25 times 10 to the 25th carbon dioxide molecules. So we're trying to find atoms in a compound, which is different than atoms in an element. If it were an element we are dealing with, oxygen, let's say, elemental oxygen, then Avogadro's number is the number of atoms in a mole. That's not the case here, though. Yes, it's still, we're going to use Avogadro's number, but that's not our last conversion factor. All right, pause the video and set it up. All right, here's the setup. Oh, I forgot to cancel moles. And 1 second. It looks like we have a mistake there. Let me fix that. Wow, did you smell that brain fart? That was pretty bad. Let's try again. Sorry about that. We're going directly from molecules to atoms. We just need 1 conversion factor, and all we need is the chemical formula of the compound. So we have 2 oxygen atoms for every 1 molecule of carbon dioxide. If we have 1.24 times 10 to the 25th molecules, we would have then how many oxygen atoms? 2.48 times 10 to the 25th. Apologies for that. Here's our next problem, but I think I want to do this together in class. This one's a little bit different as far as the labeling is concerned, and this will give us a good chance to review together in class. So please do not do this example. We can do many, many more examples if you like. So we'll just stop here. All right, thanks for watching.